So let's go through acid-base titration. So remember, a titration is to find concentration of an unknown solution based on its reaction with a solution of reagent with known concentration. Okay? We will be talking about acid-base neutralization. We're not restricted to that when we talk about titrations, but that's what you'll see most commonly. All right, so let's talk about what we're going to do. So, one, you're going to have oxalic acid, dihydrate, okay, and you're going to react it, first one, okay, you're going to react it with sodium hydroxide, you form water, plus your sodium oxalate. And these two waters, they just go into solution. So I'll just go ahead and put them down here so you know that they're there. Okay? So that's the first set of reactions that you're going to do. The first reaction that you're going to do. And your second reaction is you're going to take your sodium hydroxide solution and you're going to react it with an unknown acid. Okay? Okay, so that acid, let me just try to get that out of the highlights for you. That acid here is an unknown concentration. And again, you're going to form water and then your salt. Okay, so let me erase this and let's talk about some terms along the way. So, what are some of the terms? When we have a solution of known concentration, this is our standard solution. Okay? Alright, so just so you know, we need to develop our standard. When you have a titration of an unknown acid, we normally don't talk about concentration. Okay? This is in moles of solute over liters of solution. Because right now, we do not know our solute. So we talk about normality. This is in moles of equivalence per liter of solution. Okay, so what's the difference? So here's the thing. Normality will always be equal to some integer times concentration. Okay, most often it's going to be equal to 1. All right, so we'll be talking about getting your concentrations. It sounds interchangeable, but the difference is this. If I just take something like hydrochloric acid, I react it with sodium hydroxide. turns out if I use, let's say, 10 milliliters of 1 molar HCl, and I react it with 10 milliliters of 1 molar sodium hydroxide, okay? So you know that's going to give you, react completely and give you your water and sodium chloride. If I really look at my net ionic equation, what we're really doing is H plus OH minus gives me water. That's really the key reaction that we're looking for. And 10 milliliters of 1 molar HCl, because HCl is a strong acid, it dissociates completely. That's like saying 10 milliliters of 1 molar H plus. This is a strong base. So 10 milliliters of 1 molar sodium hydroxide is essentially saying 10 milliliters of 1 molar hydroxide. So if I look at, for hydrochloric acid, if I'm looking at 1 molar HCl, that's the same as saying that's 1 normal HCl, because it gives you 1 mole of H plus for every 1 liter of solution. Okay? So essentially, because HCl is a monoprotic strong acid, it's 1 to 1. Okay? Let's take a look at something different. Let's take a look at sulfuric acid. If we look at sulfuric acid, this gives 2 H pluses. What that means is 1 molar sulfuric acid, when I react it with sodium hydroxide, I need 2 molar sodium hydroxide to react completely with it. Okay, given, okay, so, or if I say 1 mole, I need 2 moles of sodium hydroxide. So if I look at the concentration, if I gave you a concentration of 1 molar sulfuric acid, it means that I get 2 normal sulfuric acid. In other words, what this means is I get 2 moles of H plus for every 1 liter of solution. And that occurs if I had 1 mole of sulfuric acid per 1 liter of solution. Okay? So when we do a titration of an unknown acid, we often use normality because I don't know, is it monoprotic, diprotic, okay? So we only know this part when we do our reaction, because the reaction here is still the same for my net ionic reaction, okay? So let's go through our equipment. When you read your burette, what are we doing? Okay, this reads to the 100th of a milliliter, so you'll get up to 4 significant figures. Okay, when you make your bottle of sodium hydroxide solution, you don't know the concentration. So what we first need to do is we need to establish what the concentration is. Okay, so how do we do that? Well, once we make our sodium hydroxide solution, we fill I'll reread with our sodium hydroxide solution. Okay, and when you read it, try to start exactly, slightly below the 0.00. So when you read it, this is your initial volume. Okay, and what you're going to put down below in your Erlenmeyer flask, you're going to put in your oxalic acid dihydrate, which is a solid, so it's easy to weigh the mass. And you're going to add indicators. So you add 1 to 2 drops of phenolphthalein. Okay, and this is your indicator. Okay, so once you have this, and you're going to dissolve this in about 20 to 25 milliliters of water. So now we're set to do our titration. And what this titration will do is this establishes the concentration of our sodium hydroxide solution. Okay, so let's go through and talk about what an indicator does. I think you've seen this before. Let's talk about what an indicator does, and then we'll move on to actually talk about what we're going to do after we do this titration. And then we'll go through and get you some data. An indicator changes color upon a change in pH. Okay, so I'm going to just scoot my camera down. So this changes color with pH changes. Okay, so for phenolphthalein, we can choose our indicator, and in this case, where we want to choose it, we want the color change to occur close to neutralization when it's pH 7. Okay, when my solution's neutral, where all of my sodium hydroxide and all of my acid has been used. So we use this as colorless when it's acidic, turns pink when I have a lot of base, so when it's basic. And when we do this titration, what's going to happen is, just when my solution here turns ever the slightest pink for about 30 seconds, the lighter the better, okay? So 30 seconds, you say, oh, it's still pink, okay, I'm going to stop here, okay? Then we know when this turns light pink, the moles of base that you added is equal to the moles of acid. Okay? And since we know the volume that we use, we can get our concentration. So the formula that you're going to use looks just like this. The equivalence of acid, okay, or let me just do equivalence, let's do concentration of acid, okay, times the volume of acid is equal to the concentration of base times the volume of base. In here, since we are using a solid, what you're going to do here is you're going to get moles of acid, mass of acid, convert that to moles of acid And that is going to be equal to the concentration of base times the volume of base. So when we do this first step, this first set of titrations, you're going to have this mass, you're going to have this volume, and we're going to look for the concentration. Okay? So when you do the first step, suppose you weighed out, I'll just have you do one calculation. Suppose you weighed out 0.3042 grams of oxalic acid dihydrate. Okay? So that's the mass you put in there. You put in your phenolphthalein. Okay? This is all dissolved in about 20 milliliters of water. And then your initial volume that you read off your burette is equal to 0.03 milliliters. Okay? And then you go through, okay, a sodium hydroxide solution that you made. When you're done, so you go through here, your V final is equal to, let's say, 28.22 milliliters. Okay? So, from this information, determine the concentration of your sodium hydroxide solution. Okay? And remember again, when you do the molar mass of your oxalic acid dihydrate, it's the molar mass not only of oxalic acid, but remember, you have the dihydrate. So you're going to go mass of acid to moles of acid, and we use molar mass. Okay? And then write out your balanced equation. Okay? Because then from here you need moles of sodium hydroxide. Okay? So here you're going to need your mole to mole ratio. And that's why you need your balanced reaction. Okay? Then, once you get your moles of sodium hydroxide, since you know the volume that you use is VF minus VI, just erase this now. You now can get concentration. The concentration of your sodium hydroxide is going to be equal to your moles of sodium hydroxide divided by the volume of your solution. And remember, this has to be in liters. Okay? So that's your first part. You need to get your concentration of sodium hydroxide. Once you do that, okay, so you have all your data now. So once you do that, then we're going to reset. And now you're going to have, once you do that, then you say, well, now what do I do? Well, you're going to have 25.00 milliliters. Don't forget, it means it's 4 significant figures of your unknown acid. And in this case, it's going to be HCl. Okay? And once you have your 25 milliliters of your unknown acid, because the reason it's unknown is we don't know the concentration. But now, this is your sodium hydroxide solution. And you know the concentration. This has now been standardized. So this is your standard solution because you just determined what the concentration is. And we do another titration. In this case, you're looking from knowing this, you're looking for that. Okay? So suppose we start off and your V initial is equal to, let's say, 0.07 milliliters. Okay? When you finish your titration, let's say you stop here, and your V final is equal to 22.86 milliliters. Okay? So, the volume of sodium hydroxide is going to be equal to VF minus VI. Alright? So let's go back to the other slide. And we said that we're going to use the formula, the concentration of A times the volume of A is equal to the concentration of B times the volume of B. If we're looking for the concentration of A, when we do this titration, is equal to MB VB over VA. Okay? So, MB. You determined that when we did step 1. So from the previous slide, you determined MB. VB, you know that's your base, so you're going to get here. VA is given to you right there. So from this set of data, you can now give me the concentration of my HCl solution. Okay, so in summary, what are you going to do for this lab? You are going to use the data given to you from these sets of slides, this video, and you're going to report 1, the concentration of your sodium hydroxide solution, and 2, you're going to give me the concentration of your HCl unknown. And make sure you show all your work. Okay, good luck.